Alright, so I want to talk a little bit about what generates that QRS, and then we're going to talk a little bit about the leads themselves and why the QRS looks different in different leads. Okay? So first of all, they went over very well in large group about the action potentials and what was going on in an individual myocyte. And here's the ventricular myocytes. Of course, there's different action potentials in the conduction tissue as well. Now remember, that's one myocyte, so that the only way you get that tracing is in a sophisticated lab with what we call patch clamping of a single myofibril to get that. But the heart is composed of thousands and millions of those myocytes. When they all go together, that's what you see as a QRS, a lot more voltage that can be read on the surface of the body. Okay? And remember, the QRS is really the depolarization, which is mostly occurring during this phase with sodium channels, a little bit of calcium. And the rest of the action potential is where we're starting to get down and repolarize again, which is where our ST and T wave are. So the QRS is very narrow, just correlating to this first part of the action potential. And the ST and T wave are correlating with the rest of this. Okay? Taking all these together, we can read those. Now, how do we read them, and why do the leads look the way they do? Well, the limb leads we start with are right arm, and left leg. The right arm is negative always, okay? The left arm is positive when it's from right arm to left arm, but it's the negative electrode when it's going down to the feet. The feet are both positive. So what does that mean? It means electricity going to a positive electrode is going to give you an upward deflection on your EKG. The baseline is just arbitrary. So when you have the bulk of the electricity or that action potentials all added up going towards the lead, it's going to give you an upward deflection. When it goes away from the lead towards the negative, it's going to give you a negative. So if most of the axis is hitting this way, between lead 1, you're going to get a positive deflection. If the electricity was going the opposite way, it would be negative. The feet are both positive, the left feet. So the left arm, right arm, lead 2 and lead 3 are usually going to give you an upright R wave because they're looking at electricity coming towards the feet from either the right side or the left side of the heart. So it's going to give you an upward deflection. If the heart were tilted up this way and the electricity was heading more of it towards the left shoulder because you had a lot more muscle, let's say hypertrophy, then the lead might be negative because electricities are going away from it. So those are basically our basic limb leads. Okay? Then remember the precordial leads are here in the middle and they go to the left arm, to the right arm, and to the feet. This is always negative. These are always positive for the augmented leads. So once again, normally we have electricity going from right to left, okay? And we usually have electricity going down to the feet. So typically in AVF, we would have an upright R wave as well as in AVL, okay? Now remember, all the limb leads are on the surface of the body further away from the heart. So they usually do not have as big an R or S wave as our precordial leads, which are just sitting closer. They're just closer to the electricity. So they tend to have bigger waves. Now once again on those, as we talked about, all the precordial leads are positive. So electricity coming towards them is going to give us an R wave. Electricity going away from them is going to give the opposite. Okay? So when we have the right ventricle sitting here, most of the muscle, and the left ventricle here, when the left ventricle fires, it's heading towards the lead, it's going to give us a nice big R wave. It's also going to give you an S wave in V1 because it's electricity heading away from this lead, heading that way from the left ventricle. And we'll get to that when we look at those things. So just understanding the leads, and the electricity always goes towards the positive lead. So as I mentioned, how does that translate into an EKG? Well, as I said, all EKGs are standard, 12 leads. 1, 2, 3, ABR, ABL, ABF, V1 through V6. And if you just look at the precordial leads, notice that we go from a small R wave, a little bit of an S wave, bigger R wave, bigger S wave, more R wave, some S wave, a lot of R wave, smaller S wave, almost all R wave with very little S wave, and same thing here. This is what we call R wave progression. As we go from the right side of the chest, anterior, are wrapping around towards the left lateral chest coming this way, the R waves get bigger because V6 is sitting on the lateral part of the chest. That's where the LV is. Same with V5, V4. So we get more electricity in these leads because the electricity from the left ventricle is heading right towards them. Okay? Alternatively, the S wave in V1 and V2 is electricity going away from these anterior leads, which means that's also seeing left ventricle forces going towards the shoulder or towards the left side away from these precordial leads on the front of the chest. So what does that mean? It means an R wave in like V5 is very similar. It's basically showing you almost the same thing as an S wave in V1 or V2. One's heading towards and one's heading away. It's the same electricity. So we look for R wave progression. Okay. Once again, I mentioned that the foot electrodes are positive. So look, AVF is positive. Okay. Lead 1, going from right arm to left arm, negative arm to positive arm, is upright. So that would be, if you drew something like this and said, here's an axis, okay? Here's 0 degrees, here's 90 degrees. The normal heart is positioned this way. If this is AVF, and this is lead 1, I'm going to have a positive R wave here and a positive R wave here because that's the normal axis the heart depolarizes down and to the left and towards the feet. That's the way the heart points. So it makes sense as it depolarizes, that's where the electricity is heading. So lead 1 and lead AVF are how we look for what we call the axis of the heart. And this came up, people want to know how you determine the axis. That's just all the electricity heading one way. Okay. Now, if you had more left ventricle, one of the hearts in lab has a bunch of hypertrophy. And so when it depolarizes, it's still going from the right arm to left arm because it's a lot more left ventricle heading towards the left. But instead of heading towards the feet, there's more LV up here and it's heading up towards the left shoulder. So now my axis has shifted past 0 degrees to minus 30 degrees. And these are just made up by people who invented this. Why they chose 90 down there, I don't know. But this is minus 30 towards the shoulder. So in that case, you would expect lead 1 to still be positive, but guess what? AVF wouldn't have a big R wave, it would have a downward, an S wave. Because the voltage is no longer going towards the feet, it's going up towards the shoulder and the head, the opposite direction of AVF. The other thing you might see with that would be that which lead is at minus 30? The left shoulder. Which is the left shoulder lead? AVL. So you would definitely see a positive R wave, and it might be quite larger than normal in some cases if you have hypertrophy. So this would be what we call left axis deviation. And there's other right and other things we'll talk about. So those are only two leads you look at axis. Okay. And that's kind of how all that comes together in terms of how we look at the leads. All right, thank you.